All right, let's do some math in regards to figuring how the second derivative works for figuring out our maximums and minimums. So we're back to the question that we did in lesson one about the first derivative test. We've got the function x cubed, 6x squared, 9x plus 2. We did the factoring. We found critical numbers, which in this case is where the slope equals 0. And we knew from the past chart of going from increasing to decreasing at -3, it's a maximum. And from decreasing to increasing at -1, it's a minimum. We just want to show you the math like we talked about in a previous video, how the second derivative gives you that exact same information. So the second derivative is 6x plus 12. Again, from our previous information, we know where the slopes are 0 at. The slopes are 0, -3, and -1. So what we want to know then is algebra that shows us when you put -3 into your second derivative, so 6 times -3 plus 12, which is -6. Because the second derivative is negative, your function is concave down. All the tangents are pushing down on the curve. So if you are concave down and a 0 slope, that means you're a maximum. So you don't actually need the chart to tell you that going from increasing to decreasing, you can find the second derivative that's concave down and a 0 slope. And the same thing for the other 0 slope at -1, you find the second derivative value of it. So when you put -1 into the second derivative, you find it's 6. Because it's a positive number, it means the function is concave up at that 0 slope. So if you're concave up in a 0 slope, you're at a minimum. The same thing your chart told you, you're going from a region of negative slopes to a region of positive slopes, you're at a minimum. So we can use the second derivative test along with your critical numbers, your slopes of equaling 0, to figure out that you've got maximums and minimums because of being concave down with a 0 slope and being concave up with a 0 slope. So that's the first one we'll touch on. The second example, again, this is one we did in our first lesson with first derivatives. So we went through and we found critical numbers. There is no places where the slopes are undefined. Your slopes are only going to be 0. So again, we did this nice little table and we talked about increase to decrease. What we're saying is, though, we don't actually need that table to help us figure that information out. What you have is you can take your second derivative, right? So 3x squared minus 3, find the second derivative, put in your 0 slopes. -1 was a 0 slope and +1 was a 0 slope. When you put in a 0 slope and you get -6, that is telling you are concave down. So you're concave down at -1 with a 0 slope. So concave down at -1 with a 0 slope means you're at a maximum. When you put 1 into your second derivative, you get +6. So when your slope is 0 at x equals +1, you are concave up, so you're at a minimum. So again, you're concave up with a 0 slope, so you're a minimum. I've got this nice little red dot here in the middle, 0.0 and 1. That's the critical number for the second derivative. So your second derivative changes from negative to positive, right? So you've got negative second derivatives, it's pushing the function down. Now you got positive second derivatives because it's pushing the function up. So if you find f prime prime of 0.5 or f prime prime of 2, right, you're going to find positive numbers there. So you can find a critical number for the second derivative. It's 0. When x is 0, it's not concave up, it's not concave down, it's called the point of inflection. And again, how do you find points? You go right back to your original function and you plug in the value. The same thing that you don't find f prime of -1 to find a maximum value, you find f of x at -1 to find the maximum value. Right. So we've got some things to figure out here again. Second derivatives tell you concave up, concave down. If it's 0, though, it's a point of inflection. So one more example in this video. Let's do C. Again, this is a question you did earlier. We did the math, we did the factoring. We found we have 0 slopes at 0, 4, and -1. We did this beautiful little table. We talked about you're going from negative slopes, so you're going decreasing function, positive slopes increasing. So when you go from decreasing to increasing, you know you're at a minimum. You're going from increasing to decreasing, you know your maximum. So that's nice. That's all the first derivative test. So again, we don't actually need that information. Let's just move this to the forward so that we don't see anything there at all. What we really need to just work with, table's nothing wrong with the table. What you really just need to work with, you just need to work with these zero slopes. Because when you have a zero slope and you put -1, just working with the smallest number first, the second derivative of -1 gives me +20. A +20 second derivative just tells me my graph is concave up in that area. -1 is a zero slope. So my two thoughts, I'm concave up and a zero slope. That means I'm at a minimum value at x equals -1. Second derivative of 0 is -16. -16 is telling me I'm concave down in that area. F prime dy dx at 0, okay, was also 0. So that's zero slope at x equals 0. And when x was 4, the slope was 0. When x is 4, it's concave up. So when x is 4, you're at a minimum. So you can use that information to help you draw some sketches. And again, these points here now are points of inflection, because when you go from concave up to concave down to concave up, you got to have a place where it's 0. So you find your second derivative, and then you'd go through all kinds of fun math here. Look at that. We get to bring back the quadratic formula, something you haven't probably seen since Math 20, but it's something that you can review, right? You got your A, your B, and your C. You plug them in, you simplify. We don't like to use decimals. We don't have to. So root 84 is 4 times 21, so 2 root 21, and we can simplify. So we know the x values where we have our points of inflection. And if you're really ambitious, you could figure out the y values there as well. Okay, so short version is you don't need to use the table to figure out maximums and minimums. You can use the table if the table works, because the question works out well. But some questions later on, especially when we're doing trig, it's actually going to be really nice to understand that you can find concave up and concave down with zero slopes to solve your problem. All right, that's it. It's time for you to do some practice on your own or some more examples on your own.